So we're going to take a look at one more example, starting with the domain. In this case, I have to factor the denominator in order to find those domain restrictions. What multiplies to positive 12 adds to negative 8 would be negative 2 and negative 6. So setting those equal to 0, my domain restrictions, x cannot equal 2 or 6. We can't divide by 0. Vertical asymptote, when I look at this function in factored form, I notice it has a common factor of x minus 2 in the numerator and the denominator. If we simplified this function, those would cancel. However, it's still a domain restriction of the original function, which leaves a hole in the graph at x equals 2. The other one that does not cancel, x minus 6, that would be a vertical asymptote. So we have a vertical asymptote at x equals 6 and a hole in the graph at x equals 2. Looking for any horizontal or slant asymptotes, we look at the degree of the numerator and the degree of the denominator. The degree of the numerator is 1, the degree of the denominator is 2. When the degree of the numerator is smaller, you have a horizontal asymptote at y equals 0. X-intercepts set the numerator equal to 0 if it's not a hole. That numerator cancels with the denominator, leaving a hole in the graph, not an x-intercept. So now we know that this hole would occur at 2, 0 exactly. So we have no x-intercepts because there's nothing left in the numerator to set equal to 0 after we cancel that common factor. Y-intercept, substitute 0 for x. And I remember the factored form, so I'm going to substitute it into the factored form. We get negative 2 over negative 2 times negative 6, which is 12, giving us negative 1/6 for our y-intercept. If there's symmetry in the graph, we check that by replacing x with negative x, and we get, what was it, x squared minus 8x plus 12. So when we simplify, the numerator is simplified. The denominator, we would get x squared plus 8x plus 12. Now be careful on this one because it's tempting to factor a negative out of the numerator and the denominator. But think about if you're canceling a negative 1 over a negative 1, you're actually factoring out a positive 1. So you really only want to factor a negative out of the numerator or the denominator to see if it equals the original function, not both. Typically I go for the numerator. If I factored a negative out of the numerator, and actually you could even bracket this off and have the negative on the outside, because what you're checking for is to see, does f of negative x equal the opposite of x? We can tell right away that this is not the same function we started with, so that's when you factor the negative out to see if it has symmetry around the origin. And this function is still not the function we started with, so this function is not symmetric. All right, so plotting our intercepts and our hole and our asymptotes, we have, let's see, vertical asymptote at x equals 6 and y equals 0. So I'm going to count each of these as 2 this time. And we had the asymptote at 0, and we had a hole in the graph at 2, 0. Now because this is on the asymptote, it may not actually be a hole in the graph, depending on if our graph crosses the asymptote. Remember, it's okay to cross the asymptote close to the origin. The asymptote is for when x gets really big or really small. And our y-intercept was 0, negative 1/6, so that's about here. And it has no symmetry, so this doesn't help us at all. So we're going to set up a t-chart. We will have to use some positive and negative values to see what happens, especially on both sides of that asymptote. And I'm just going to start with -2, -1. We already know what's happening at 2, so I'm going to jump to 4. You may not need to substitute in all of the values to get an idea of what the graph is doing, especially once you're using those asymptotes. So our function was x minus 2 over, and I'm just going to use the factored form because I think it's simpler to work with. So replacing our x with -2, we get -4 over -4, which will cancel. Really, we can use the simplified form of this function. That would be easier as well. So we get 1 over -8. Substituting -1, we get -1/7. Substituting 4, we get -1/2. Substituting 8, we get +1/2. And substituting 10, we get 1/4. All right, so plotting these points, let's see if that gives us an idea of what's going on with the graph. All right, so -2, -1/8, which I can tell it's just getting close to my asymptote already, so I really don't need any more negative x values to figure out what's going on. 4, -1/2. We have 8 1/2 and 10 1/4. So this one, it looks like, using my asymptotes, the graph is doing something like this. That should be a little bit of a curve. And off to the left of my vertical asymptote, it doesn't really look like I'm using my hole at all. So I'm going to assume it's going along the lines of this, using those asymptotes as guides for my graph. And again, write at least one question. It may be a question you actually had on any of the videos, or it may be a question you think one of your classmates might have on the information, or it could be a question you think I would ask of you to see if you understand the material. And then summarize your learning. Again, feel free to rewatch one of the videos and just listen if you need some additional help or support in getting that summary ready to go for tomorrow.